No.
So, what do banks expect when they give you the money? The bank has two choices. They can keep the money themselves, they could invest their money and make a profit off of it, or they could take the money that they have and lend it to you. Now, what do they want out of those two scenarios? Well, if they kept the money, they're going to make some money. If they lend you the money, they also want to make some money, and they want those two amounts to be exactly equal. So what happens is, if they keep it or they lend it, they want their profit to be equal. They want their profit to be equal. Let's call this profit. Is it two T's or two F's?
I think it's one F and one T.
One F.
That's right.
I want to do double T's and double F's. Oh well. I love my double letters. Now, if they keep the money, their P is the principal of the money that they keep. They would earn some interest on it compoundedly. They would keep it as a lump sum. So they put it in and invest it someplace. They'd earn a little bit of interest on it over a period of time. They want that amount of money to be the same as, well, if you borrow money from a bank, how do you pay it back?
Very careful.
Monthly. You do this. You pay them back monthly. So that would be, I'm not going to call it D, I'm going to call it R right now. But it's the same formula. In their eyes, you paying them back is the same thing as them putting money into a bank account and earning interest on it. So if they keep the money, this is what happens to it. It earns interest, it grows compound interest style, but it's a lump sum. If they lend the money, they're only going to get it back every single month in little payments. And they want these two amounts to be exactly the same. So what happens here is you solve for P, the principal of the loan. If you solve for P algebraically and all that other fun stuff, you get P is equal to, you're going to love this, Rn, which is usually 12, divided by little r, parentheses, 1 minus, parentheses, 1 plus, r over n, raised to the negative, that's important, it's a negative exponent, nt. This is how you figure out a loan, where P is loan, principal, and big R is required monthly payment. So in the end, this formula is keeping a bank's portfolio exactly the same. The money they make keeping it, the money they make lending it becomes the same. For instance, for example, Joe is buying a car that costs $27,500. He will put down 20% and take a loan at 4.5% over 6 years. For remaining balance. Oops. How much will his monthly payment be? Oh, I hate word problems. Oh, it hurts to write on. It's easier to write on a piece of paper than it is on a board. All right, so Joe's buying a car that costs $27,500. He will put down 20% and take a loan at 4.5% over 6 years for the remaining balance. He's going to make monthly payments, of course, on this. How much will his monthly payment be? Well, first things first. Never work with a formula until you write it down, and that's not it. P equals capital R, N, which is usually 12, divided by little r, parentheses 1 minus, parentheses 1 plus, little r over n, raised to the negative nt. And then just plug in what you know. Do I know P?
Yes, if you.
What is it?
27.
It is not $27,500. It's 20% off of $27,500. So how do you find 20% off of $27,500? What was my way of doing it?
How much you pay,
Which would be
80%.
80% of it. So we're going to do 80% of the cost. So that would be 0.8 times $27,500, which comes out to be
2200.
22,000
Even.
even? Oh, cool. So he's only going to borrow $22,000. He's going to pay the rest of it up front, which turned out to be, what, $5,500? So he's going to pay $5,500 down, and we're only interested in the loan, so I'm going to do that 80% rather than the 20. So that's what P is equal to. So this gets $22,000. Do I know the required payment? That's capital R, required payment, required monthly payment. Nope, leave it alone, R. Do I know N?
6 years.
12. Will you stop putting time in for N? 12. R is 0.045. 1 parentheses, 1 minus. It's a little different than the systematic savings, which is parentheses, parentheses. This is just 1 parentheses, and then 1 minus the compound interest part. We'll run out of room. Raised to the negative, N is 12, T is 6. And then a big parentheses at the very end. Let's do it really quickly here. There. Now, of course, the first calculation you really should do is that negative 12 times 6, which is better known as negative 72. So when you get down here, it'll be caret negative 72. Now be careful. Do not use your minus sign. There's a little negative sign next to the decimal point. It's in parentheses. You have to use that when you say negative. When you say minus, like here, it's 1 minus, you use the minus sign. But up here, it's negative 72. So you have to use that little one. Now, of course, the only thing you can type in is all the numbers to the right of R. You can't type in R, so you can't deal with the 22,000. It's on the other side of the equation. So type in 12 divided by 0.05 parentheses, and then the rest of it. Let's see if you get the. Is that better? 62.99. So this turns into 22,000 is equal to. Now here's that thing again. The more decimals you put in, the better your answer is going to be. The less decimals you put in, the worse your answer is going to be. 62.99.
62.99.
That's the thing. If you round too much, you're going to get a very bad answer. If you round a little bit broader, you're going to get a better answer. I highly suggest 4 decimal places. So I would write 62.996. Oh, that would actually be 4 decimal places because the next one would be 0. Next one would be 0. This will give you a better answer. Times R. How do you solve for R? Divide both sides by that ugly number. 62.9960. 62.9960. And we'll get R is equal to. Oh. What'd you get? 349 point,
349.228.
so 2, 3.
23.
This is money, so you're going to round it to the nearest hundredths. This is how much he's going to pay per month. All right. So here's my next question. He's paying this off at 349.23 for 6 years, right? So my question is this. How much did he pay in total? And how much of this loan is interest? So how would I find out those two answers? So A, what is the total installment? Whatever. In other words, how much money came out of his pocket? And B, how much interest was he charged?
We paid 25, 144, 56
Well,
total.
you jump into answers. I could care less about the answers. I care how to
Is there?
get there. So how do I find out how much his total installment
Time
is?
your multiply your payments by 72.
All right, so you take your $349.23. It's amazing how many people don't understand that, by the way. If you want, you can multiply by 12 months every single year and 6 years total. Or you can multiply by 72. Both of them work. So how much money came out of his pocket?
25, 144,
25, 144,
56.
56. So out of his pocket came $25,000, rounded, $25,000. Now remember, he only borrowed $22,000. So anything that's different between how much he pays and how much he borrows must be interest. So my interest is
3,000.
your total installment minus your principal. It's just a neat little formula to kind of help you out. So your interest is $25,144.56 minus $22,000 for a grand total of
$3,144.
$3,144.56. That's a lot of money. $3,000 more than what he borrowed. This interest, is it divided evenly up through all the payments? No. And that's an interesting little fact. Like I've been saying, most of the interest is paid at the beginning of the loan. Very little of the interest is paid at the end of the loan. To find out how much interest you're paying on each one of the payments, that's called a loan amortization.
Oh.
So guess what we're going to do next?